Hey guys, so this is Unit 2, Lesson 3. Should be a quick video. Let's hope we get it. Alright, so we are doing helper definitions and properties. So the first and very important thing when it comes to this unit is naming angles properly. So we're going to be naming an angle using 3 letters with the vertex in the middle. So the vertex being where it changes its angle, so that point of, rotation. So our vertex in the middle is E. So whatever angle we choose to name, E has to be the second letter. So let's do this guy right here. So we would name this angle with our angle sign A, E, D. I now know that I start at A, I go to E, and I end at D. Now say I wanted to do D, E, A. It means the same thing. I start with D, I go to E, and then I end with A. So it it's a roadmap for where I'm going and how much my angle is. Okay? So we could even do this one right here. So then that would be angle B, E, C. Or we could even say C, E, B. Either way is fine, because it's just a roadmap to tell me, okay, I'm starting at B, going to E, and then going to C, or the other way around. Okay? So, now that we know those are the angles, let's erase our highlight, and now name an angle using a number that is assigned to that angle. Okay, so say I had this angle, our first one, so angle AED. I want to name it angle 1. So then our other one, this would be 3. So then I would say angle 3. And I automatically know that angle 3 is this angle right here. So it has 2 names if we label them with a number. Okay? So then the last thing that we need to recognize is that if we say the measure of angle DEB, which is this angle right here, we would say M angle DEB. So the measure of angle DEB. So if I'm calculating how big it is or how small it is, I would say measure. Okay? So now let's move on to vertical angles. So vertical angles are the angles opposite of each other when 2 lines cross. Vertical in this case means they have the same vertex. So our vertex for our little picture here, and I'll even zoom in, we have this shared vertex. So we can see that 72 is across from 72, 65 is across from 65, and 43 is across from 43. And they all share one point, that corner point or vertex point, okay? And they're always going to be congruent, so that's why all of those angle measures are the same, okay? Alright, so then let's move on to perpendicular lines. If 2 lines are perpendicular, they are at right angles to each other. So we have AB is perpendicular to CD. So these 2 lines are perpendicular to each other. So this angle right here is 90 degrees. This angle right here is 90 degrees. This angle right here is 90 degrees. And this angle right here is 90 degrees. And we would say that they cross at E. So they are perpendicular at E, because that is the shared vertex. Alright, and then if we want to write this formally, then we would say line AB is perpendicular to CD, and that upside down T means perpendicular. So this means perpendicular. Alright, so then we can say all the angles within here are right angles. So whenever we have a measure of some angle, in this case we'll do AED, whenever this is 90 degrees, then we can say the angle of AED is a right angle. Okay? So just a little bit of proof for you. Okay, so let's move on to reflexive property of congruence. So any shape is congruent to itself. So this triangle here is congruent to itself. This circle right here is congruent to itself. This square right here is congruent to itself. I know it's kind of silly, but we actually have a wonderful name for it. So it's called the reflexive property. Okay, so it comes into play when we have a shared side. So we have this triangle right here that shares a side with this triangle. So our top triangle shares a side with a bottom triangle. And the shared side is this one right here. So we would say AC is congruent to itself. Now how would we say that? Well, we would say CA. Okay? Or you can just say side AC is congruent to side AC. It means the same thing. Okay? This will come into play when we do proofs. Okay? Alright, so, but if they're not sharing the side, like over here, they're not sharing the side, it's not touching at all, so we cannot use that same property. Okay? They have to be sharing that same side. Alright, let's move on to our next property. So we have midpoints. Now it's kind of what you would think. It is a middle point. That's what a midpoint is. The point in the middle of a line or whatever we're defining. So again, a point in the line segment that divides it into two equal parts. So if something is in the middle, that means it's going to be divided in half equally. So we have, in our case, H is the midpoint of GK. So this entire line. Alright? So that tells us that this line right here is congruent to this line right here. Okay? And we would formally write that as GH is congruent to HK. Okay? Alright, so let's move on to our next one. And this is our last one. We have perpendicular bisector. So we could even break this down. Perpendicular, you know, remember this little symbol. And bisector meaning, again, it's going to divide into two. Okay? So we have our formal definition. Perpendicular bisector is a segment or a line that cuts a segment into two equal parts at 90 degrees. So we know that AB is the perpendicular bisector of CD. So it divides this line in half. So now we can say segment CE is congruent to ED. And then we can also say that this angle right here is 90 degrees, this angle right here is 90 degrees, and this angle right here is 90 degrees, and this angle right here is 90 degrees. Okay? So it's very straightforward definitions from us. Okay? So if you can just review this on your own, and then you will be golden. And that is it for today. Have a good one.